Everyone, so today's topic is going to be HCF and LCM, and we are going to discuss the concepts related to that, and then we'll solve few questions based on HCF and LCM. So one of the very important ideas also per se, because in a lot of the calculations in between somewhere you might have to calculate these HCF and LCM. So first thing we have to know is how do we calculate it and what are the different methods to do that. So let's first try and understand the term itself, which is HCF, which if we break it down further, it means it is highest common factor. Now all the words are very important. So highest has to be obviously the biggest number. Common is when you'll have more than one numbers, then you can take common out of that. And then obviously factor. So factor is a number which divides our original number completely. So that is called as the factor. So let's take an example very quickly. Let's find out the HCF of 24 and 60. So suppose you don't know anything, the least thing that you can do is try and find out the factors of both 24 and 60. Basically numbers that will divide 24 and 60. These are the factors, and then common, so the highlighted ones are the common factors, and out of them we need the highest one. So highest one out of all these numbers is 12. So automatically the HCF of 24 and 60 becomes 12. But obviously every time we cannot keep on doing this, that is list down all the factors and then take common and then choose the choose the highest one. So there are a couple of ways in which we can figure that out. One of the method which we have been learning since school days is called as factorization method. So let's see what to do in that method. So what we have to figure out is start dividing these numbers with the same number. So let's find out. So for example, both these are even numbers, so they both can be divisible by 2. You are left with, let's say, 12 and 30 now as the numbers. These both are again even numbers, so again we can divide them by 2. So we are left with 6 and 15, for example. And eventually now we can say that these both numbers are divisible by 3, for example. So if you divide them by 3, you are left with 2 and 5 as the number. So 2 and 5, now these numbers 2 and 5 that are left, they are not divisible by any particular common factor, and that is the point where we need to stop here basically. And whatever factors that we have taken out common outside on the left side, we have to multiply them all. So 2 into 2 into 3 gives you same answer, which is 12. So 12 is the HCF of 24 and 60, and this is the way to calculate that using factorization method. Now see here, if your numbers are good, what advantage it has for you is, if you know tables, you can straight away would have said that these both numbers are divisible by 12, for example. So 12 twos are 24 and 12 fives are 60, and you straight away would have reached at this place, and this entire time can be saved for you. So that is the whole other reason altogether that we have been talking about this again and again, that your numbers have to be good overall, which helps you in general for the calculation and the preparation part. So this is your answer, and this is the way to do that. Now there are two numbers, three numbers, four numbers, doesn't matter, same method you have to do. Until what stage you have to do, till this particular stage you are supposed to do, where whatever numbers are left are not divisible by any particular same number, then you are gonna stop at that point. So that is the way to calculate it using this one method, that is factorization method. Let's talk about other method, not prime factorization. Prime factorization is kind of similar to factorization, but there is one more method which is called as division method. Now how do we find out HCF using a division method? This part is something that is slightly new for you guys. So let's take a example. I mean, 24 and 60 same numbers. What we have to do here is we have to start dividing the bigger number by the smaller number. So we'll start dividing 60 by 24. So if you start dividing 60 by 24, 24 to the 48, remainder becomes 12. Now comes the new part. whatever is your remainder for stage 1 becomes your divisor for the next stage, for example. So 12 is gonna be the divisor now going forward. So you're gonna divide by 12, and which number you're gonna divide? So you're gonna divide 24 by 12 basically. So you get 12 twos are 24 and remainder is 0. Now again, same thing. You have to keep doing the same process again and again and again till you reach the remainder 0. And there will be one stage definitely where you will have remainder 0 as the calculation, and then you can get that answer basically. So and whatever divisor gives you the remainder 0 becomes your answer, final answer. So here 12 as the divisor, we got the remainder 0. So hence 12 becomes the HCF of both these numbers basically. So these are the ways in which you can calculate HCF. Whichever way doesn't matter honestly, as long as you get the right answer. It just you have an option of two methods, whichever you feel like using. Do that and make sure you get the right answer doing the calculation. So that's for HCF people. Let's go to the second part, that is LCM. Let's talk about LCM. So again, let's break down the words first of all. It is least common multiple. Multiple is exactly opposite of factor. So multiples are basically those number we can say which are gonna come in the table of that number basically. And common again, so has to be more than one, so then we can take common out of that. And then the least common multiple, that is the smallest number, the first number that normally comes in the table is the LCM basically. That is what the rough understanding is. Let's take the example. For example, same number 24 and 60. Let's first find out the multiples. These are few multiples of them. They will be infinite because you keep adding 24 or you keep adding 60, you keep getting the new multiple, the next multiple rather. Now we have to choose the common ones. So common ones, these are the ones which have been highlighted in the blue color. But again, the requirement is it should be the smallest one. So out of these all, the smallest one is clearly 120. So answer has to be 120 basically. So this is the very basic idea to do that, but obviously we are not gonna follow this way. This is just a rough understanding for your reference. The actual method is again same as that of factorization. So let's do that. So same number 24 and 60, let's start dividing these numbers again. So again we can start from the scratch, or both are even numbers, so let's divide them by 2. You are left with 12 and 30. Again let's divide by 2. You are left with 6 and 15. Now these numbers are divisible by 3, for example. So you are left with 2 and 5. Now, if you remember that in the case of HCF, we used to stop here. The reason was very simple, that 2 and 5 are not divisible by the same number. So we are not going to go ahead. But in case of LCM, we have to extract all the factors basically. So we're not going to stop here. We're going to divide this by 2 as well as 5 eventually. So till all the ones are not reached at the bottom stage or at the last stage, you have to keep doing it till that particular stage for LCM. So that's a slight bit of difference when it comes to HCF and LCM for the calculation basically. And now comes the interesting part for calculating the answer of LCM. What we'll have to do is we'll have to multiply all these numbers with each other. So when you multiply all these numbers with each other, you get the answer as 120 basically. But here what we will do is we'll try to derive a formula also for this LCM. So if you remember, this 2 and 5, we stopped in case of HCF because they were not divisible by any particular number basically. And because they are not divisible by any particular number, so going forward, we are gonna call them as uncommon factors basically. So the idea here is, because 2 and 5 are not divisible by the same number, there is nothing common factor coming out from them. So henceforth we will call them as uncommon factors. So what we can, going forward we can say this is that actually LCM is a combination of both the scenarios, that is common factors as well as uncommon factors, and hence a simple formula also for us, that LCM is product of both the things, common factors which is HCF which is 12 already, and then uncommon factors which is 2 and 5 which is 10, and hence combining them you get the answer as 120. So this is the way to calculate LCM, and this is the method to do that. Now, going further, this is only one method to calculate LCM. There is one more, prime factorization, but again, you may not need to know that. That is absolutely okay as long as you get the right answer, basically. So, sometimes what happens is that the numbers that you get are not the normal integer numbers, they are sometimes decimal numbers or fractional numbers. So let's say if you have fractional numbers and you want to calculate their HCF or LCM, then there is certain formula that you have to remember, and that formula is for HCF of fractions. You have to do HCF of all the numerators and LCM of all the denominators. And for LCM, it is exactly opposite. You have to do LCM of all the numerators and you have to do HCF of all the denominators. Now, simply saying what, if you know the fractions, you will know all their numerators and denominators as well. So all you have to do is calculate it somewhere separate outside and just substitute those numbers, substitute these calculations here in this structure, and you get the final outcome, basically. But yes, one thing that we have to be very careful of, which a lot of the people miss at certain times, so make sure you don't miss this as an idea, otherwise your answers will be wrong in that case. So the idea is, whatever fractions that you have, they should always be in a lowest possible form. If they are not in the lowest possible form, then we have to first get them in the reduced form, lowest possible form, and then apply the formula. If you don't reduce them and directly apply the formula, then there might be some issues sometimes with the numbers, and the answer will be incorrect in that case. So do make sure to remember this tip as well, which will help you to avoid that error going further. So these are the ideas that we need to remember or understand when we are studying HCF and LCM as a core and the simplest of concepts. Of course, when we are going to solve questions, we are going to apply these things. We are going to add a few new things as well, and then eventually the application part of the concept for solving the question. So let's go there. So let's start with the first question. Here is the one. So again, I would request you all to pause this video, try this yourself, and then check the solution. So we have to find out the HCF of 279 and 465 and 775, for example. And how do we do that, basically? So to do that, the very easy and the simplest way would be, you can either do factorization or you can do division method also. So for three numbers, if you are doing division method, that is something that is new for us. So let's explore that. So what happens is, you can start with any two numbers out of the three numbers, basically. So let's start with 279 and 465. Let's start dividing them with the normal division that we know from school days. So 279 ones are 279, remainder is 186. Then if you remember the concept, the remainder becomes the next divisor. So now we have to divide by 186 and the number will be 279, of course. So 186 ones are 186, remainder is 93. We have to divide now 93, you have to divide by 93, and 186 will be divided by 93. So obviously 93 twos are 186, remainder is 0. So we'll stop here at this particular stage. So what does this mean actually is that for 279 and 465, the HCF is 93. But if you guys remember, for us, it was not two numbers, but it were There were three numbers that they had given us. So what now we have to do is we have to divide the third remaining number by 93 all over again. The same process one more time basically. And that is how we will get the final and the correct answer. So let's start doing that. So let's divide 775, the third number, by 93. So 9 8s are 72. Yes, somewhere around that number. 93 8s are 744. Remainder is 31. So now we have to divide 93 by 31. When you do that, 31 3s are 93. Remainder is 0. So this means 31 is the HCF of 93 and 775. And 93 was already the HCF of 279 and 465. So automatically, for all three numbers combined together, the correct answer of HCF becomes 31. And this is the way to do that using a division method basically. You could have done this with factorization, and that is absolutely okay. Just new thing that we are exploring. So let's say there would have been a fourth number. Then what we would have done is we would have divided that fourth number by 31, and then we would have gotten the correct answer for the remainder zero case, the divisor value, basically. So this is the way to do that. The first question, basically. I hope you have understood. Moving on to the second one, we have to find out the HCF and LCM of all these three fractions. And again, one very, very important part that you have to remember or keep in mind, rather, that is don't directly apply the formulae, because you can clearly see some of these fractions can be reduced further as well. For example, the first one and the last one. So you have to first reduce them and then apply the formulae basically. So let's reduce them. So if you divide them by 2, the first one becomes 12 by 25 and the last one becomes 16 by 15, for example. And now for these new numbers, we have to apply the formula. So you remember those formulas probably. So for HCF, what we have to do is we have to take HCF of all the numerators, and for LCM, we have to do it LCM of all the denominators. So let's do that. I'll do factorization very quickly. So 12, 4, 16, we have to find out HCF. The common factor is 4. 4 threes are, 4 ones are, 4 fours are. Clearly, there is nothing common now from all these numbers. So I think the answer becomes 4 only for HCF of numerator. Yes, then LCM of denominators. So 25, 5, 15. I have to find out LCM. Let's first take the common factor. So common factor is 5. 5 5s are, 5 1s are, 5 3s are. This becomes the HCF because now there are only uncommon factors. And since we are doing LCM, we have to collect all. And then eventually 3 as well. So now we can multiply all of them. So 25 3s are, that is 75. So LCM value is 75 basically. So this is only HCF ka answer. Same way for LCM, what we'll have to do is LCM of numerators. Now 4 was the HCF. Again, we have to extract the uncommon factors as well, basically. Once the uncommon factors are extracted, then we are done. So that is 4 4s are 16, 16 3s are 48. So numerator ka LCM is 48, 12 4 16. Yes, and now HCF of denominators, which we had already done, which is 5 basically. So here we are. The answer for HCF is 4 by 75, and for LCM it is 48 by 5, which gives us answer option 1 as the answer for this particular first question. This is the way to calculate that basically. I hope you are understanding what we are doing here. That was question number 2. Let's move on to the third one. which says the product of two numbers is 1985 and their HCF is 5, we have to find out their LCM. Now, for these next couple of questions, we have to be aware of a concept, and that concept first we need to discuss basically, and then we will apply that here, for example. So, what is that concept? And then obviously do remember this and do make a note of this also somewhere wherever you are making your notes. So let's say uh, for two numbers, let's define the HCF as H, for example. And if you know the HCF, then both these numbers can be written as H into A and H into B, where A and B are supposed to be co-prime to each other. That is the condition for A and B. A and B cannot be any random numbers. They have to be co-prime to each other, and obviously H is your HCF basically. That's the idea. Now let's say I have, in general terms we are talking. So now let's say I have to multiply these two numbers. So I have to find out the product. So I have to basically multiply these two brackets. If I multiply these two brackets, I will have two versions basically. One version is this h square into AB, and the other version can be, what I can do is I can split this h square as h, one h separate, and the other h I can put it inside with A and B as well. So for product, I have two options, either h square AB or h into A into B. Basically, that's the product of two numbers. But the thing is, we have to write them in terms of a word-based formula, and that is why you have to be very good with these ideas. So if you remember, H is defined as HCF basically. So this formula becomes what? HCF ka square, because h ka square, and A and B, if you remember, A and B has a condition that they are supposed to be co-prime. For example, co-prime numbers are the numbers which have only one common factor between them, which is one only. And because they are co-prime, we can also say that these numbers are actually uncommon factors. Now, why uncommon factors? Let's think about that for a moment. So, for example, because they are co-prime, so there is only one common factor between them, which is 1. And apart from 1, there is no other common factor between these numbers. So, they automatically becomes uncommon factors as well. And hence, this A and B becomes uncommon factors. UCF, for example. So, that's the first version of the formula, that product of two numbers is HCF ka square into product of uncommon factors. Or the other version can be what? Let's try and explore that as well. So the other version is obviously H is there, which is HCF, and the other version is H into A into B, where H is the HCF again, and A and B we just now saw they are uncommon factors. Now think about this again. If you multiply common and uncommon factors, what do you end up getting as? So obviously you end up getting as LCM, because common and uncommon factors combined together will give you LCM. So you have another formula for product of two numbers, which is HCF into LCM. So we have two formulae. Product of two numbers is HCF square into product of uncommon factors, or it is product of two numbers is equal to HCF into LCM. So do remember this entire theory and this entire concept. Basically, the starting point is very crucial, and that starting point is, you know what? This is that starting point. That if you know the HCF of two numbers, which is let's say H, then the numbers can be written as H into A and H into B, where A and B are co-prime to each other. And then you obviously perform whatever operations that you want to perform on then those numbers. We are doing product because our question deals with product basically. But we have to remember this theory so that we can use it directly whenever henceforth is required. Now comes again the tricky part here. If you, let's say, solve this question using the second formula, which is a straightforward formula, that product they have given, which is 1985. HCF they are given, which is 5, and they are asking LCM. All you have to do is solve this. 1985 divided by 5. You solve this question, you get the answer as 397, which is also present in the option. But unfortunately, it is slightly incorrect. And it is incorrect because of the fundamental problem that it has. And what is that fundamental problem? So now think about this. There are two numbers whose multiplication is ending in 5 and their HCF is also 5. Now what does that mean for you? So if product of two numbers is ending in 5 and their HCF is 5, instead of more than product, this HCF part is the most critical part. So their common factor is 5. Now think about this. किसी भी नंबर से 5 कॉमन कब आ सकता है? तो ऑब्वियसली जब वो दोनों 5 के मल्टीपल्स होंगे तभी आ सकता है, वरना पॉसिबल ही नहीं है 5 कॉमन आएगा एज अ कॉमन फैक्टर फ्रॉम दोज नंबर्स. बट हियर they are asking us to find out the LCM also, which is another common multiple. Now think about this. दोनों नंबर खुद 5 के मल्टीपल्स है, बिकॉज उनमें से 5 एज अ कॉमन फैक्टर बाहर आ रहा है, वो 5 के मल्टीपल होने ही चाहिए. एंड हमें चाहिए उनका कोई कॉमन मल्टीपल चाहिए, विच आई होप यू अंडरस्टैंड हैज टू बी ऑल्सो अ मल्टीपल ऑफ 5, जो ये 397 नहीं है. एंड दैट इज द रीजन कि ये आंसर में प्रॉब्लम है बेसिकली. यानी अकॉर्डिंग टू द डेटा जो आंसर आना चाहिए था वो मल्टीपल ऑफ 5 आना चाहिए था, बिकॉज नंबर्स खुद 5 के मल्टीपल है, उनका कॉमन मल्टीपल भी 5 का मल्टीपल होना चाहिए. बट आंसर आ गया सॉल्व करके एक फॉर्मूला 397 जो 5 का मल्टीपल है ही नहीं. सो दैट टेल्स अस इट्स अ वेरी क्लासिक एंड अ न्यू केस फॉर यू गाइस, व्हिच इज समथिंग कॉल्ड एज डेटा इनकंसिस्टेंट. यानी जो आंसर आना चाहिए था वो नहीं आ रहा है, कुछ और ही आ रहा है. एंड जो डेटा था और जो आंसर आ रहा है वो दोनों एक दूसरे के साथ कंसिस्टेंट नहीं है. डेटा के हिसाब से आंसर आना चाहिए था मल्टीपल ऑफ 5, सॉल्व किया आंसर आया कुछ और विच इज नॉट अ मल्टीपल ऑफ 5. दोनों के बीच में कंसिस्टेंसी नहीं है, इसीलिए इसको बोलते हैं डेटा इनकंसिस्टेंट बोलते हैं बेसिकली. तो याद रखना ये नया कैटेगरी है, नया पार्ट ऑफ ऑप्शंस है जो शायद अब तक हमने कभी एक्सप्लोर नहीं किया था. तो बी केयरफुल अबाउट दैट एज वेल. आई मीन वुड हैव थॉट अबाउट दैट. Now, there is one more way to do that. Obviously, what we can do is we can use the second formula as well. So, product दिया था 1985 और HCF का स्क्वायर. नाउ सो 5 का स्क्वायर करना पड़ेगा and we have to find out UCF. Now, turns out 5 का स्क्वायर हो जाएगा 25. तो ये जो 1985 है ये अगर आप 25 से डिवाइड करोगे तो आंसर जो है वो पॉइंट में आ जाएगा, डेसिमल में आ जाएगा, बिकॉज 1985 इज नॉट डिविजिबल बाय 25. एंड प्रोडक्ट ऑफ अनकॉमन फैक्टर्स डेसिमल नंबर्स जो है वो नहीं हो सकते. एंड इसीलिए भी हम क्या बोल सकते हैं, डेटा इनकंसिस्टेंट बोल सकते हैं. यानी जो आंसर आ रहा है वो कुछ अजीब आंसर आ रहा है बेसिकली. So that's the whole premise for this question number 3. I hope you have understood that. Very important all these things are, and this similar kind of thing is gonna come in the next couple of questions as well. So make sure you remember this concept very clearly. Now, moving on, let's do the fourth question. The fourth question is the HCF of two numbers is 7 and their sum is 140. How many pairs of numbers exist? Now, clearly, same idea. हमें क्या दिया हुआ है? HCF दिया हुआ है. और अभी अभी हमने पढ़ा था, अगर हमें HCF पता है तो दो नंबर्स को हम कैसे लिख सकते हैं? H into A, H into B, where A and B are supposed to be co-prime to each other basically. तो वही हमें भी करना है अभी यहाँ पे, और h का वैल्यू हमें पता है विच इज 7 बेसिकली। तो हमारे नंबर्स क्या हो जाएंगे, 7 a and 7 b हो जाएंगे, बिकॉज h is 7 for us, HCF is 7 for us। एंड सम बोला है नंबर्स का 140 है, तो क्लियरली ऐड कर देते हैं, 7a प्लस 7b इज इक्वल टू 140। आई होप आ रहा है समझ में सबको। नाउ लेट्स सॉल्व दैट फर्दर। सो इफ यू सॉल्व दैट फर्दर, हम क्या कर सकते हैं, 7 को कॉमन ले लेंगे तो हो जाएगा a प्लस बी इज 140। जब तुम इसको सॉल्व करोगे a प्लस बी का वैल्यू आ जाएगा 7 आ जाएगा बेसिकली। इफ यू सॉल्व दैट यू गेट a प्लस बी एज, सॉरी a प्लस बी एज 140 बाई 7 विच इज 20। a प्लस बी का वैल्यू आ जाएगा 20 आ जाएगा 140 को 7 से डिवाइड करने के बाद। Now, what we have to do is we have to merge these two things together. But because we are doing it for the first time, तो मेरा एक suggestion रहेगा simple सा, that don't look at co-prime वाला part as of now. Only look at the simple part कि दो number ऐसे तुम्हें ढूंढने हैं जिनका sum 20 आना चाहिए. We have to find out two such numbers जिनका sum, the sum of those two numbers should be 20 basically. ऐसे दो numbers हमें find out करने हैं. एंड देयर कैन बी लॉट ऑफ कॉम्बिनेशंस। तो जो भी कॉम्बिनेशंस आते हैं तुम्हारे दिमाग में, जस्ट मेक श्योर यू लिस्ट देम ऑल एंड देन वेरीफाई विद अस ऑफ कोर्स। सो व्हेन यू डू दैट you realize there are 10 such combinations that are possible जहाँ पे sum जो है वो 20 आ सकता है। and now what we will have to do is we'll have to only select the ones जो क्या है, को प्राइम भी होने चाहिए। so when you start selecting them you would realize कि 19 और 1 को प्राइम है, 17 और 3 को प्राइम है, 13 एंड 7 को प्राइम है, एंड 11 एंड 9 को प्राइम है। रेस्ट ऑल द नंबर्स दे आर नॉट को प्राइम विद एनी अदर नंबर बेसिकली। सो दैट इज द रीजन ए एंड बी के चॉइसेस हमारे 4 चॉइसेस हो जाएंगे। बिकॉज ए एंड बी के 4 चॉइसेस हो जाएंगे, सो तुम्हारे नंबर्स के भी 4 चॉइसेस हो जाएंगे, बिकॉज दीज ए एंड बी will go ahead and multiply it with 7, and then you keep getting the new numbers basically, the 4 different types of numbers. Now people, that is the application of concept that we had learned earlier कि अगर दो नंबर का HCF पता है तो दो नंबर को हम ऐसे लिख सकते हैं, h into a, h into b basically. That is the way to look at it. Now, let's look at the next question. Question number 5. बोला है टू नंबर्स का HCF दिया हुआ है 7 एंड देयर LCM इज 140. हाउ मेनी पेयर्स एग्जिस्ट? सिमिलर कॉन्सेप्ट, बट LCM का फॉर्मूला अब लगाना पड़ेगा। LCM का फॉर्मूला होता है HCF इनटू अनकॉमन फैक्टर्स, एंड वो अनकॉमन फैक्टर्स जो A एंड B है उनका एक कंडीशन भी है, वो भूलना मत कि वो दोनों क्या होने चाहिए, को प्राइम होने चाहिए। We know the values. LCM is 140, HCF is 7. If you calculate that further, you get A and B ka product as 20, 140 divided by 7. Now what we have to look at is two numbers जिनका multiplication 20 आना चाहिए. So 2 3 combinations if I'm not wrong. So 4 5s are, 10 2s are, 20 1s are. That's it. 3 combinations जहाँ पे product 20 आता है दो numbers का. But then again, do not forget the possibility that A and B are supposed to be co-prime. Now we have to shortlist the co-prime scenario. So only two of them are co-prime. 2 and 2 and 10 is not co-prime. So that possibility will cancel out. So A and B, there are two possibilities possible, and basis that there are there are two possibilities for the numbers also basically. And this is the way to look at it. So that is question number 5 for us. Let's look at question number 6. There is a number which when divided by 457 always leaves a remainder of 1. Find the smallest such number. Now the next five questions, out of them three are gonna be one of its type, and there's a specific way to solve those questions. The only thing that will change is the numbers, but the language and the structure will remain the same. So make sure you remember that structure or the kind of language that is there, and a appropriate way or a formula to solve those questions basically. So what to do here? There is a simple formula, and the language will be something like this only. Always there is a number which is divided by 3 4 numbers, but always should give you a same remainder. That is the key part. Whatever that can be the remainder, 1 2 5 doesn't matter, but it should be the same remainder. If that happens, what you have to do is you have to remember a simple formula, and that formula is this one: k into LCM of divisors plus common remainder. And this is the structure of all such numbers. Now don't bother about this entire part on the left hand side. You can skip that. Just remember these two things. So LCM of divisors is, that is 457 ka LCM, which is 140, and we have to multiply that with k, hence 140k plus the common remainder. In our case it was 1, hence the formula has become 140k plus 1. And we were supposed to find out the smallest number here. A lot of the people, what they do is, and this is a error that normally happens, is they will go with the options. In such questions, if possible, never go with options, otherwise you will not understand the game actually, and you will end up marking the wrong answer and lose your marks. So, what we need to do is, the entire value of the number now depends on the value of k, for example. And for smallest number, your k has to be 0. Now, think about it. If you substitute k as 0, your number becomes 1 itself. The reason is 140 into 0 is 0, 0 plus 1 is 1. Now, a lot of people might not agree with this, but I'll explain you. If you remember, what was the condition? Number after divided by 457 should give us a remainder 1. Now, think about this. 1 after divided by 4 is not divisible, so gives you a remainder of 1. 1 after divided by 5 gives you a remainder of 1. 1 after divided by 7 gives you a remainder of 1. So I hope you understand. They were asking for the smallest number, and for smallest number k is 0 and number is 1. So correct answer for this question should be none of these, which is answer option 5, for example. A lot of people say it is 141, but let me tell you, 141 is the second smallest number basically. Why second smallest number? Because then k becomes 1, and if k becomes 1, the number is 141. But if you remember, people, they were asking for the smallest number, and smallest number is not 141, it is 1 actually. So this is the way to do that. Just simply remember the structure for all such kind of question. Now only thing that, as I said, we can change is the numbers. They might say एक number है जो 8 9 13 से divide होता है, हमेशा remainder 2 देता है. You can easily find out whichever number that you want to find out. Smallest number, largest number, this number, between this range, whatever you can do. So just remember that structure and that formula, which of course will help you to solve such similar kind of questions going further. That is question number 6 for us. Let's talk about question number 7. Again, one of its type, but we have to identify that first of all. So they are saying now we have to find out the second smallest number. So first key part is this, not the smallest, the second smallest number, which when divided by 4 leaves a remainder of 2, divided by 5 leaves a remainder of 3, and divided by 7 leaves a remainder of 5. Now, how do we identify this type? So, this type is basically a type where the difference between the divisor and the remainder is constant, is same every time. and you can verify that, because in the first case we are dividing by 4 and we get a remainder of 2. So 4 minus 2, difference is 2. When we divide by 5, we get the remainder 3. Again 5 and 3 ka difference is 2. And lastly, when you divide by 7, you get a remainder of 5. So again the difference between those two is 2. So it is constant difference between the divisor and the remainder. So this is the other type, the second type of question that can come here. So again, the only thing that can change is they will change the numbers. But if the structure is same, which you have to identify first, this pattern, and if you can understand that and you think or you figure it out that it is the same way, then again there is one simple formula that you guys have to remember in that case, and then your number becomes this. So again, the same process, only remember this thing, nothing else in such type. Again 457 ka LCM is 140, and the difference between the divisor and the remainder should be constant always. In that case the difference was 2, in this case the difference was 2, hence the general type of the number is this. Now they are asking second smallest number. Now think about it. For the smallest number, if we substitute as usual, considering the previous mindset, if we substitute k as 0, then the number becomes minus 2. But the problem with this number is, if we divide minus 2 by 4, we don't get the remainder of 2. We get the remainder of minus 2 only, which is not satisfying the main condition. And hence, for this reason, the k value cannot be 0 here for the smallest number. So that means this one more point also you need to remember, guys, that you cannot go with the fixed mindset that every time the value of k should be 0 for the smallest number. No, it doesn't work like that. The reason being, it all depends on the general type of the number. In the previous case, it worked because the general type was like that. But in this case, it is not happening, it is not working out. So, hence, we cannot go ahead with this particular scenario. I hope you understand that. Now, this means what? That to calculate the actual value, we have to change the value of k. So let's change the value of k. If we change the value of k as 1, for example, then the number becomes 138. Again, they are not asking for the smallest number, if you guys remember. They are asking for the second smallest number. So clearly, second smallest number in that case has to be, the value of k should be 2 in this case. So if the value of k is 2, then the number becomes 142 is 280. 280 minus 2, which is obviously 278 for that matter. So the second smallest number, the answer is 278, which is answer option 3 for this particular question, basically. And this is the way to calculate such kind of questions. Now, let's talk about the next one, eighth one. It says there are 132 mangoes, 84 bananas, and 144 watermelons. If equal number of fruits are distributed to every student in the class in such a way that each student gets only one type of the fruit, then what is the minimum possible strength of the class is what they are asking. So one thing is here that is very very important. This language, minimum possible strength of the class. Now think of yourself as the distributor of this scenario, and you are supposed to give this fruits to all these students in this particular manner and this particular condition. Think about it. The 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 student should be least possible number, the minimum possible strength of the class should be there. So how the distribution needs to be happen, if you are in charge of this distribution. So clearly the opposite. If you need minimum possible strength of the class, the distribution has to be as high as possible. And when we think of that, it clearly happens to be the HCF. And HCF of what? So clearly HCF of the numbers, that is 132, 84, and 144. So let's very quickly calculate that. Both are even numbers. So if we divide by 2, this becomes 66, this becomes 42, this becomes 72. All these numbers are divisible by 6. 11, 7, and 12. Now, 11, 7, 12 are not divisible by any particular number. So we'll stop here. So clearly, HCF becomes 12. So now this means we have to give 12 fruits to every student, basically. But they are not asking how many fruits to every student. They are asking how many kids are there. What is the maximum, sorry, what is the minimum possible strength of the class? Now all we have to do is now start giving out 12 mangoes to every kid, and these will get over in 11 students. Then 84 bananas will get over in 7 students, and 144 watermelons will get over in 12 students. So all we have to do is add these three numbers. So 11 plus 7 plus 12, that is 18, plus 12, that is clearly 30. So the answer for this question is 30 is the minimum possible strength of the class, basically. And that is the answer for question number 8 in that manner. Let's do question number 9. Question number 9 is the third one of its type wala question that we have been discussing. Two we had done. Both of them had a particular formula and a way to identify. So do remember that. The ninth one is also kind of similar structure. So the language is the key part in all these types of questions. So it says when the numbers 5361, 5685, and 6333 are divided by the same three digit number, you end up getting the same remainder. Find out that three digit number is what we are supposed to do. So, again, the language will remain something similar. There will be four, five numbers, three, four numbers, whatever. They are divided by the same number. Every time you get the same remainder. This is the key part, basically. Now, what to do in such kind of questions? So, the first thing that we do is we take the difference between two consecutive numbers, basically. So, we have to find out the difference between 5685 and 5361. And if you do that, 5 minus 1 is 4, then 8, that is 2, and then obviously 3. So, 324 is the difference between the first two numbers. Then we have to take the difference between the second and the third number also, the consecutive numbers, that is the key part. So 6333 minus 5685. 13 minus 5 is 8. 12 minus 8 is 4. 62 minus 56, that is 6. So 648 is the difference. And also, people, remember always, It has to be the difference between consecutive numbers only. It cannot be difference of first and third, and so on and so forth. Let's say if would have been a fourth number, we would have taken the difference of that as well, and so on and so forth, basically. Okay, so we have to take the difference between the consecutive numbers only. Now, what we have to do is to find out the answer. They are saying that all these numbers, they were divided by the same three-digit number. So similarly, what we have to find out is now for these two differences, we have to find out a three-digit common factor. What is that supposed to mean? So we have to find out ऐसा कौन सा थ्री डिजिट नंबर है, सेम थ्री डिजिट नंबर जो ये दोनों नंबर को completely divide करेगा basically. So we can use options, and when you use options, you'll realize these both numbers are divisible by 324 because 324 का डबल करोगे तो 648 मिल जाएगा, 324 का हाफ करोगे तो 162 मिल जाएगा, एंड 108 भी हो सकता है. यानी this and this all three answers are possible. यानी that three digit number can be any one of these three numbers basically. So clearly cannot be determined is the correct answer for this particular question. Let's say if they would have changed this to these numbers are divided by a two digit number, देन हम भी यहाँ पे चेंज क्या करते, टू डिजिट कॉमन फैक्टर ढूंढते. सो इट विल अगेन ऑल डिपेंड ऑन द नंबर का टाइप या नंबर के लैंग्वेज में, क्वेश्चन के लैंग्वेज में क्या दिया है उसके ऊपर ये सब डिपेंड करेगा, ये सारी चीजें. तो make sure you remember these concepts, and again the language is very critical because that is the identification part actually. तीन चार numbers है divided by the same number, every time you end up getting the same remainder basically. That is the way to calculate. I hope you guys are understanding whatever we are discussing and the way that we are discussing. So these were the three questions that I spoke about. Like that is, as we said, one of its type wale teen questions basically. Now let's try the next one. The last one which says there are three cans ABC which contain 65 liters, 50 liters, and 160 liters of milk respectively. Okay, so A, B, and C. A has 65, B has 50, and C has 160 liters of milk respectively. Then there is a bucket that is used to remove milk from the can, and there are conditions only full bucket is removed and the same bucket is used for all the can. Now look at the wording, same bucket, so it should be common. You have to figure out such things also. And also, after the bucket was used to remove the milk, there were 9 liters, 8 liters, and 6 liters in can ABC respectively. So this is leftover after removing. So 9 liter, 8 liter, and 6 liter is left behind after removal basically. The first thing obviously we'll have to do is we'll have to figure out how much is removed from each of the cans ABC. So A had 65, left with 9 liters now. So how much is removed? Obviously 56 liters is removed. B had 50, left with 8, so 42 is removed. And C had 160, left with 6, so that means 154 is removed from each of these cans. And same bucket is used and full bucket is used. Clearly we have to find out the size of the bucket, and that size of the bucket is gonna be common to them, common to all these numbers, which should be HCF of all these numbers. So HCF of 56, 42 and 154. We have to find out that. Let's do factorization. Even numbers, so they are divisible by 2. Now 28, 21, 77. All are divided by 7. 7 fours are, 7 threes are, 7 elevens are. Now there is no common factor left. So the HCF is 14, which means the size of the bucket is actually 14 liters. But they are not asking the size of the bucket. What are they asking really? How many buckets full were removed in all? Now think about this. A bucket of size 14 liter is used and 56 liters is removed from A. So how many buckets were removed from A? So clearly 4 buckets because 14 fours are 56. Then for 42 liters of B that was removed using 14 liters wale bucket, 3 buckets must have been used. And for removing 154 liters from C with the bucket of size 14 liters, 11 buckets must have been used basically. And hence the total buckets that they have used is gonna be clearly 18 buckets, which is answer option 3. So total 18 buckets full of were removed from all three combined together, that is can ABC, because the size of the bucket is 14 liters basically. This is the application of HCF LCM in word based problems, and that is the reason why you have to know that basically. Folks, that's it about HCF LCM. Go through this one more time in detail, one of the very important topics. And if you still have any questions or queries, then feel free to let us know. We'll be happy to help you guys. Thank you so much. Have a great day. We'll meet again in the next part of number series.